Welcome to Math Mini Lessons. This video is for third graders who are practicing for the New York State exam. In this video, we're going to go over all the multiple choice questions. Now, I put a link in the description so you can print out this same test. Here's my advice. Take the test yourself. Practice doing the problems, and then come back and watch this video where we can spoil all the answers for you and show our strategies for solving these problems. If you get the answers right, fantastic. If you have a question or you're getting something different and you don't understand why, put those questions in the comments. And we'll actually section it off page by page, so if you get the answers right on one page, just skip to the next one. Here's something else you need to know though. On the state test, there are 30 multiple choice. Most of them are on day 1, the rest are on day 2. But when you print out this copy, only 16 of the 30 questions are given, meaning 40 are going to be missing. And that's okay. At least you can practice those 16 with us and then use this video to see how you did. Now, let's jump into today's practice review. Here are the answers for the first page, 1 and 2. So you get D and D. If you had those right, awesome. Skip to the next section. If you had something different or you kind of guessed, stay right here. We'll go through it together. With this first one over here, we want to know what factors make the equation true. And we have this fact family. 8 is a factor and something else makes 72. So some of you probably know your math facts to know that it's just 8 times 9 makes 72. Or you played around with fact families, you've probably seen something like this, where you have 72 and on the bottom you know 8 and some number. And you can figure out, well, I know 8 times a number makes 72. Or you're already thinking, why don't I do 72 divided by 8? And I'll get that same number 9. That works. Other things I've seen kids do, I've seen some kids just skip count all the way until they get to 72. You can do this. It does take a little bit more time though, but you can count until you get to 72 and then figure out, well, how many times did you have to count 8? 1, 2, 3, 4, 5, 6, 7, 8. There were 9 groups of 8. So that's another thing you could do. And I've even seen some kids draw this out with making circles with 8s and just drawing 8 inside and drawing another 8 inside till they get to 72. I will say that those methods take up a lot of time. So knowing your fact families is probably the fastest way, but at least you have a backup plan. If you do make a mistake though, like you draw one too many dots in a circle or you miscount, you might have an error in your answer. So just look out for that if you end up with an answer like 71 and 72 and it's close to 72, but it's not 72. Let's look at number 2. In this one, we want to know the area of the figures. And what I can give you for this one is, if this one was done, and I'm going to color it in just so we have it, I would have a full array. I would have 4 groups of 10, which would be awesome because then I can just skip count. I've seen kids do this 2 different ways. I've seen some kids count all of them until they get all the way to this box. You can do that. Again, it just takes more time and this is an untimed test. I've seen some kids make it faster, get there faster by just saying, well, I have 10 here, so I have 20, 30, and I would have 40, except I have 40 and then 1 taken away. So I've seen some kids do this, 40 minus 1 to get to 39. Either one will work. You can either count up all the squares or you can see this pattern using an array. All right, hit pause and jot this one down into your notes and we'll go to the next page. Now remember, I told you we skipped some questions. So we skipped 3 and 4 and we went right to 5 and 6. So your 2 answers are D and C. Check with your booklet, and if you got the same answer, skip to the next section. If not, stay right here. We'll go over it together. In the first one, we know point R is on the number line, and we want to know which two fractions are equivalent to point R. Meaning, I'm going to have two fractions probably with different denominators. How do I know that? Well, if they had the same denominator, they'd have to have the same numbers on top, and that wouldn't make sense. So watch what I'm going to do here. I'm going to, I have a hard time with number lines. I'm going to turn this into a rectangle and break it into equal pieces. And I like doing that because then I can see the fraction in another way. I'm going to do that carefully. And I'm going to start drawing lines. 1, I'm going to leave the R there. 2, 3, 4, 5, 6, 7. Now I know some kids, when they're drawing their lines, they go, I have 7 lines, I must have 7 boxes. So here's the trick. Just count. 1, 2, 3, 4, 5, 6, 7, 8. I actually have 8 boxes in there. So don't get tricked by drawing 7 lines and thinking you only have 7 boxes. All my boxes are the same size. I have 8 of them. So these are eighths. Oops. I want to count them up. So I have 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7. Did I miscount somewhere? 1, 2, 3, 4, 5, 6, 7. No, I got it right. And 8 eighths. I'm always checking. Now I'm going to highlight until I get to the R. So I see my first fraction, 6 eighths. And that means, well, I'm looking at this one over here. I'm looking at A and C, and they don't have 6 eighths, so I know I can just cross those two out. And my answer is either going to be 2/4 or 3/4. Okay, now I'm going to try and break this up so that if I only had 4, how many would be in each 4? So I have 8, and I have 4 people, everyone would get 2. So I'm going to repeat what I said. I have 8 pieces, eighths. But if I share with 4, every 4th would have 2 eighths inside. Okay? So this is 1/4, 2/4, 3/4, and why did I almost write 5/4? And I'm going to highlight again so I can see the equal fractions. And there we go. Another way I can represent this is 3/4. And that's how I know D is the answer and not B, because I have definitely more than 2/4. Let's look at number 6. Madeline has exactly 7 coins in her bag. Each coin has a mass of 5 grams. What is total mass of the coins in her bag? So I'm going to draw her 7 coins. And I know each one is 5 grams. I can see some kids drawing the 5 little dots inside, but I'm just going to write the number 5. And I'm going to do some skip counting because I know each one of these is 5. So I have 5. Let's see, 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. Or you can look at it as, if I'm skip counting, 5, 10, 15, 20, 25, 30, 35. So either one of those will do. You can either have 5 inside and just skip count, or I know some kids just skip count as they go. Either way is fine. All right, hit pause and jot this one down into your notes. We did some skipping again, so here are the answers to 15 and 16. They're both B's. If you got them, keep going to the next section. If not, stay here. We'll go through it together. In 15, we have a rule, and a rule created this pattern: a number, 9, a number, 21, and 27. I need to figure out what those 2 missing numbers are in the pattern. So I'm going to start by just rewriting. And just by looking at this, I know I'm going to have to do some backwards thinking because I don't have enough information to figure out the rule from the beginning. Like I don't have a starting point, so I don't know where I'm starting from to get to 9, or 9 where I'm going to for this one. Same thing with here. But I do have 21 and 27, and that's the one where I can figure out a pattern. To get from 21 to 27, I can add 6. So I'm going to use that add 6, and I'm going to work backwards. Okay? So we already know this one, 27. Instead of adding 6, I'm going to subtract 6 to get to 21. And now I'm going to subtract 6 again to get to that missing number. 21 minus 6 is 15. And then I'm going to subtract 6, and I should get 9, and I do. 15 minus 6 is 9. And subtract 6 again. 9 minus 6 is 3. So my two missing numbers are 3 and 9. I could also check to make sure it's true here on the top by just adding 6 to make sure. 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 6 is 21, and 21 plus 6 is 27. So that was my strategy for here. I could only use the 21, 27 to find a rule, and then once I find a rule, I'm working backwards. Let's look at number 16, and I want to know which fraction is equivalent to 4 over 4. Now, as soon as you see this, I know I have 4 parts out of 4 whole things. So kind of looking at this way. So I know that this is equal to 1 whole. So I have the whole thing. And I know that when the numerator and the denominators are the same, that the fraction's equal to 1 whole. So I'm going to look to see which one of these choices has the same numerator and denominator, and that's only this one here, 2 over 2. So I have to recognize that. All these other ones were more than 1. This is equal to 2, so I have 2 parts out of 1. I have 4 parts out of 1, and here I have 2. 4 out of 2 is 2. Hit pause and jot this one down into your notes. Here the answer is for 18 and 19, C and B. So check and see what answers you got, and we're going to jump into 18. 18 can be a little spicy. There are 2 ways I can think of 3 ways of solving this problem. I'm going to show you them in a second. What we're doing is we're going to try combining the 2 rectangles to find the total area. So one thing kids can do is we can cut this piece up into 2 rectangles. That means I could either cut it this way and make 2, or I can cut it this way and make 2. I will say that the way you cut matters, because if I cut down this way, then this 10 is going to get split up into 2 numbers and makes it a little harder to figure out. If I cut this way, the 8 gets cut up into 2 numbers, but it's a little easier to see what those 2 numbers are over here on the other side. Whereas with 10, I would know that this part is 4, and I would have to figure out that this part is 6. So either way will work. So let's say you decided to cut it. I'm going to cut it down this way first. So you cut it down this way, and now you have a 4 by 8 rectangle. And on the other side, remember I said this was 4, this is 6. I have a 4 by 6 rectangle. So these are the 2 parts we have, and we can just add them together. So 4 times 6 is 24. 4 times 8 is 32, and I can add them up together to get 56. So that's one way that you can solve this. The other way you can actually cut this and solve it, and this is called decomposition, is what if I cut it the other way? And I had a long rectangle this way, and this rectangle is 4 times 10, and I had a little rectangle over here, which is a 4 by 4. So 4 times 4 and 4 times 10. So 4 times 10 is 40, and 4 times 4 is 16, and I still get 56. So either way you cut it, you'll still get 56. It absolutely doesn't matter as long as you remember what the new dimensions are. So that's decomposition. I'll show you another cool way that I've seen kids do this. I've seen some kids go and say, well, what if I had the whole piece? and I just figured out which piece was missing and subtracted. I thought this was a super cool strategy that a kid used, and they just cut it and they imagined, well, the whole thing would be 10 times 8, and they would just subtract this little part over here, which is 6 by 4. So they would do 10 times 8, which is 80, minus 6 times 4, which is 24, and they'll still get 56. So this, I used to call this strategy like the missing piece, where you had to figure out what the missing piece is, and that can also work. So you can decompose or you can find the missing piece. Either way, pick the strategy that works for you. If one of these made the most sense, do that one. And that's how you get 56. All right, let's go to the next one, number 19. And we want to know which expression is equivalent to 4 times 3 times 2. So one thing you can notice is when I'm multiplying numbers, the order doesn't really matter. So you could just look to see, do I have it another way of multiplying a 4, 3, and a 2? And you see it here. And it's the exact same thing. I'm just doing what's in parentheses first. 4 times parentheses 3 times 2 is 6 is 24. And if you had done it the other way, 3 times 4 times 8. I'm sorry, I put the 8 because my brain went too fast. 4 times 2, so that gets 3 times 8, which is also 24. So some kids can look at it and do that. If that doesn't make a lot of sense to you and you would rather try a different way, here's my advice. I would go and do each one and see which ones have the same value as 24. Okay, so you can just go in and try that. So for example, the first one, A, I have 2 plus 7, that was in parentheses, and that gives me 9. 9 is not equal to 24, so I know that can't be it. Or if I went to D, 3 plus 8. 3 plus 8 would give me 11. 11 is also not equal to 24, so that wouldn't work. So you can use either one, whichever one makes the most sense to you. All right, hit pause and jot this down into your notes. Okay, here's the answer for number 20. It is B. Let's jump on in and see why. We're looking for the point located at 1/4. So when I think about 1/4 and I'm doing some type of estimate, I know that 1/4 is going to be, and I kind of cut numbers in halves, and I know that 1 out of 4 would be is going to be less than half and closer to the 0 side than the 1 side. So that's just how I start predicting when I start thinking about where it should be on a number line. So knowing that, looking at A and B, it doesn't make sense that 1/4 is going to be in the middle. That's a no. All right, so now that I've kind of eliminated some, I have 2 choices that are closer to 0. What I'm going to do again is make a visual, because visuals really help me. And I'm going to just draw my rectangle down and cut it into those pieces. So here's my first one, and here's the second one. And now I can look to see with the first one, I have fourths. So I have 1/4, 2/4, 3/4, and 4/4. So I could absolutely see that this point is at 1/4. So that's perfect for me. I also see a lot of kids who will start writing, especially if you're starting to use rulers. This is pretty helpful. Here's 0, here's 1, and they might write the fourths right on that line. Because I have one piece here, so that's 1/4. Here is 2/4. When you get to this line, it's 3/4, and at the end of the line is 4/4. And that's how a lot of times we start transferring what we know about fractions to rulers. Because we know it's not until I get to this line that I have 1 piece out of 4, 2 pieces out of 4, 3 pieces out of 4, and 4 pieces out of 4. So hopefully that really helps when you start using rulers and you don't just think the number is in between those 2 numbers. Now, so why does D not work? Here I drew 7 lines, but do I have 7 boxes? No. 1, 2, 3, 4, 5, 6, 7, 8. So these are eighths. And this one over here is 1 out of 8. So this line, this point is at 1/8, which is not equal to 1/4. All right, how do I know that? Because even though my numerators are the same, my denominators are not. So 1/8 cannot be the same size as 1/4. Nope. All right, hit pause and jot this one down into your notes. Here are the answers for 23 and 24, D and C. Check your answers and stay on if you need a little extra help or you want to see how I solve it, or move on if you got it and you feel super confident. For number 23, we want to know how many square units are needed to find the area of a rectangle that is 48 square units. So think of it, I have some type of shape that has 48 square units inside, and the question is asking me, how many squares are you using? How many square units? It's actually so easy that some kids may get confused. I have 48 square units, so I need 48 square units. That's the only way I could make it. Because that's what a square unit is. Okay, so here you go. And I know that there's some kids who are like, it can't be that easy, and that's where they may have made another one. But just think about your tiles. When you have your square tiles, if something has an area, if it takes 48 of those little tiles to cover, the question is asking how many tiles do you need to cover something that has 48 square units? I need 48 tiles. That's it. Let's look at number 24. This is kind of like the last one we did, where we want to know where on the number line 4/8 will be. So again, I'm going to make a prediction. 4 out of 8 is between 0, 1, and halfway. So if I have 4 out of 8, that's definitely halfway, because I have 4 out of 8, and that means 4 would be missing out 8. Yeah, I have a half. So you could do the same thing here. You can look to see which one is halfway, and you can predict it's going to be R because it's halfway. And then you can use your rectangle strategy again to break this up. And so now I have 8s, 1, 2, 3, 4, 5, 6, 7, 8s. And I'm going to put the numbers here. So this is 1/8, 2/8, 3/8. Yeah, we were right. R is at 4/8. 5/8. Oops. Oh, 6, 7, 6, 8, 7 8s, and 1 was at 8/8. So yeah, R was the correct answer. P was at 1/8. Q was at 3/8. Very close. So I can see why some kids pick Q. And S was all the way at 7/8, which is close to 1 whole. All right, hit pause and jot this down into your notes. And I hope this strategy really helps you, because it really helps me see it, as well as figure out how do I find these same numbers on a ruler. Here are my answers for 26 and 27, A and D. So you have them, awesome. Move to the next section. If you want, stay over here and I'll show you different ways of solving both problems. For 26, I actually found 3 different ways, and I started drawing the first one out so it wouldn't take as much time in the video. Here's the problem. A student has 27 cupcakes in the box, 10 have chocolate frosting, 11 have vanilla, and the rest have strawberry S. So what I'm going to do is, one way you can solve this is to draw all 27 circles. And if you have no idea how to start a problem like this, you can do this and represent all 27. It's a lot of drawing and it takes time, but this is an untimed task. This is not the fastest strategy, but it's a great starting point if you really struggle with stuff like this. All right, so the first 10 cupcakes have chocolate, so I'm just going to put a C for chocolate. All right, 10 cupcakes have chocolate. 11 have vanilla, so I'm going to put B's in 11. And the rest have strawberry. And so this is a nice, easy way of showing how many have strawberry. You can see 6 of them have strawberry. So that's one way, which is to create a really strong model. And if you have scrap paper, you can do this, but this one takes the most time. Here's the second way. I can use a number line. Starting with 0, and I know I have to get this to 27 cupcakes. So I might start by saying, well, 10 of them are chocolate. And then another 11 have vanilla. So these are my chocolates. These are my vanillas. So what number do I have already with cupcakes? I have 21. And so how many of them have strawberry? Well, to go from 21 to 27, I have to add 6. So S has to be equal to 6. That's a second way of solving this problem. Here's a third way, and it's probably the fastest way, but doesn't mean that it's the best way for you. I could make a number sentence where I know that chocolate plus vanilla plus strawberry is equal to 27 cupcakes. I know that. I'm going to tell a story problem, and now I'm going to put in the numbers I have. So 10 for chocolate plus 11 plus for vanilla, I don't know what S is yet, is equal to 27. And now I'm going to make this simple. So I know that 21, if I add up the chocolate and vanilla, I have 21. 21 plus some number makes 27, and then your brain is either going to say, well, then it just has to be 6, or your brain is going to do 27 minus 21 and get 6. Either way will work. All right, so again, you don't have to do everything, but do the one that makes the most sense to you of where you are with math. I will say again, this one probably takes the longest to do. When some kids get really fluent, I see them moving to this level. And this is definitely moving towards middle school math, where we start representing story problems using numbers and letters. But any of these ways will work. Let's look at number 27. The area of a rectangle shown below can be found using square units. What is the area in square units of the rectangle? Again, I can think of 2 ways you can do this. One, since we know each of these is 1, you can literally count each one until you get to the final one over here. So you could just count them all. So that's one method. Count all squares. 2, a little bit faster, you can skip count by rows, where I can see I have 1, 2, 3, 4, and they're all equal. So I'm just going to skip count by 4s. 4, 8, 12, 16, 20, and 24. Either one will work. You can either count all of them, or you can skip count. Or 3, you can look at it as an array. And what I mean by that is, I see a rectangle that has 4, 5, 6. And you can see why I have 6 rows of 4. So 6 times 4 is 24. Either way will work. Doesn't matter which one you want to use. So again, use the one that makes the most sense to you. Again, the ones that are probably quicker are the second and the third strategy, but if you have to use the first strategy because you're not good at skip counting yet, that's okay. You just need more practice, but you will get there. Hit pause and jot this one down into your notes. Here are the answers for 28 and 29. We're so close to the end, B and A. So let's get started with the first one, 28, and it is a 2-point problem, 2-step problem, and it's a little spicy, so I'm just going to kind of show my work there for a little bit because there are 3 different ways I can think of solving this problem, and the first one is the easiest way. Okay, which is just to draw a picture. Mr. Juarez buys 5 packs of notebooks. Each pack has 6 notebooks, and he gives an equal number to his kids. So in my story problem, 2 things are happening. He buys 6 packs of 5 notebooks, and then he shares all the notebooks with 3 kids. There are 2 things happening as I tell my story problem. So the first part is I need to figure out how many notebooks he has so I can figure out how to share them. One thing I see a lot of kids do in the beginning, again, when they're just starting out, is you might draw out what does that look like, and they might draw, here's 5 groups of 6. So they're just drawing 5 circles, and there's 6 dots inside. And when they count that, they have 30. So there are 30 notebooks. And then they try to do an even share. And what I mean by an even share is they take the 30 and they just split it up, like 1, 2, 3, 4, 5, 6, and they split all of them up until they give out all 30, and then they count inside and they see that they have 10 inside. So everyone got 10. That's one way that you can very easily solve this problem, is just creating a model of figuring out the groups and then sharing. So that's one model. Again, the easiest one, the one that is probably the simplest to understand, probably takes the longest to model because I have to represent each number. So that takes the most time. Another way you can do this is by recognizing I have 5 groups, 5 sets of notebooks. So you might go and say, all right, I have 5 notebooks, and I'm just going to start skip counting inside. So 6, 12, 18, 24, 30. So great if you know how to skip count. So you have 30 notebooks, and then you know you're going to share them by 3. So 30 divided by 3 is 10. That's a second way. And you know this is a little bit faster when you know how to do your skip counting. Skip counting is super awesome. It does help a lot, but it is hard for a lot of kids, and it doesn't always happen by 3rd grade. I know 6th and 7th graders who still struggle with skip counting. Here's the third way, which is to just represent the entire problem, which is, let's see, let me write this out. I have 5 packs of 6. Oops, earlier I wrote 6 packs of 5. That was my fault. I have 5 packs of 6. So 5 groups of 6. They might just say, oh, that's 5 times 6. That's 30. And then share. 30 divided by 3 is 10. So that one again is probably the fastest, but it's only fast if you know how to do that mental math pretty fast. Either way, for any of these strategies, your answer is 10, and each kid gets 10 notebooks. Let's look at number 29. What fraction is equivalent to 2/8? So equivalence, this is, and a lot of kids kind of struggle with this. One thing I can do is I can try to think, are there other ways that I can share with 8? And that's one way I think of it. Like, I know that I can share, I can give everybody one group of 8. Make sure I got 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So this is one way I can split up 8. I don't have to color it in. Are there any other ways I can evenly share 8? Yeah, I can give everybody 2. So I can have 2 groups of 4. Not my prettiest picture, but that's okay. So I'm thinking about how I can share 8. Okay, so I can have 1 group of 8, or I can have 2 groups of 4. So I can split up 8s into 8s or into 4s. So here's this model doesn't help me too much, so I'm going to redraw it a little bit, because I know I can have 2 groups of 4. So what I'm going to do is I'm going to try drawing it. I'm going to draw the same way again, and now I'm going to put 2 groups of 4. Okay, so I have 4s. So these are 8s, and now I have 4s. And now I can think, if I have 2 8s, that is the same as 1/4. So this modeling is really hard for a lot of kids, but it can help me figure out how I can make equal fractions with certain pieces. Now, could I share 8 into 6? Could I do that? Try and think, if you had 8 pieces of something, could you share that with 6 friends? You can't. If I try to give everybody a piece, 1, 2, 3, 4, 5, 6, yeah, I don't have enough. I can't share with 6. There's no equivalent fraction I can make with a 6. Not with a whole number. It doesn't work. And you can do some kind of math like that later when you get up to middle school, but right now in 3rd grade you can't. There's no way that I can make my 8 right now the same size as 6. So that's why I can cross these out, and then I can just figure out how many 4ths are equal to 8s. The other thing we know, why can't 2 4ths be the same as 2 8ths? My numerators are the same, but my denominators are different size pieces. So I can't have 2 pieces that are the different sizes be the same. So I can cross it out. This one was a little spicy, and this is a hard topic. We'll share more in 4th and 5th grade how you can compare fractions in other ways. That makes sense. But it will make sense for where you are in math. We did it. We made it all the way to the last multiple choice problem, which is number 30. And in this one, we need to figure out, we have a shaded array and an unshaded array. What are the combined? So I need to, when I combine, I know I'm going to add them, add the 2 pieces together. And I need to know which expression can I use to find the total area. So we're going to start with this shaded part of the array. How can I represent this? One is I could just count all of them again, but remember I'm talking arrays, so I'm probably going to use 2 dimensions, my length and my width. So here I have 1, 2, 3, 4, 5. Here I have 1, 2, 3, 4, 5, 6. So I could represent the shaded part as 6 times 5. And I could represent it as just 30. Both of those are equivalent. For the bottom part, I have 4 groups of 6. So I could represent this as 4 times 6, or 24. Both are equivalent. So how can I find the total? I could just add them up together. 6 times 5 plus 4 times 6. That is one way for me to represent this expression. I could also just do 30 plus 24. Or I could also just add them together and get 56. Any of these ways will work. So when I look at these expressions, I notice A is very similar to what we had over here with the arrays. So I see 5 groups of 6, 6 groups of 5, same thing. 4 groups of 6, 4 groups of 6, same thing. So A is absolutely 100% equivalent to what we had. The bottom ones will not be equivalent. And if you're not sure how to do that, you could just solve them. Like maybe you don't see the pattern in there and you just decide, I'm gonna figure it out and find the answer, and you find 56 and you counted all the little squares and you go 56 is equal to 56. So that one works. That's a true statement. And you try the next one, 6 plus 5, 11, 11 plus 4, 15 is not equal to 56, so that one can't be the area. You can go to the next one, you get 30 times 24. Whoa, no way is that 56. That's going to be a super big number. And the last one, you have 30 times 4. Well, 3 times 4 is 12, so 30 times 4 is 120. And nope, 120 is not equal to 56. So either way will work. You can either recognize the pattern in the arrays and go 5 times 6 and 4 times 6. Or if you're not sure, you can actually figure out the total number inside and figure out which of these has the same value. because they're asking for just an expression that is equivalent. Well, that's it for our third grade video math marvels. We went through a whole bunch of multiple choice problems. Super proud of you for pushing through and taking the time to practice before any big test. If you had a strategy that's different that gave you the same answer, please share. I love hearing more strategies from kids, and it makes me better at what I do, and you help a ton of other kids. And if you have questions, ask them too, because your questions are questions that other kids might have as well. All right, Math Marbles, that's it for today. I'll see you in the next one. Be well.